Okay, so I finally managed to take out the rivets. I have to use all kind of tools for this to actually get this thing out. So, and the reflection is making things horrible looking. I know that. Let me adjust the exposure a little bit lower. So, it still has that rattling thing inside, and it also has the rivet pieces inside. So let's take a look at what is inside. I haven't opened this thing yet. I just undid the rivets. I haven't taken. Oh, it's taken. This thing. Okay, okay. That, see that? Ooh, and that, what? What is that weird looking thing inside? I mean, I'm not even going to touch that thing. What in the world is that? Ooh. What is that? A chicken nugget? I don't know. What in the world? And it certainly has to come out through that. So it's definitely going to be chemically bad for my health. And that is all it is. In fact, you can clearly see the two wires that is coming to. There is a circuit board inside that I'm going to take apart right now. I'm going to need another screwdriver. I'm going to use this bad boy right here, and I'm going to completely tear this thing down because I don't want this thing anymore. And the only reason I kept this thing in my attic is because the case looks really good. This entire metallic case, I can just clean that off with some acetone or something and repurpose this metallic case for some other projects and things like that. So that is the only reason I believe I kept this thing. I don't want to touch that, but still. Okay, there's a diode. If you can see that, there's a diode. There's a resistor. Let me see. Let's see what is the thing going on here. The AC mains comes straight to this point. It goes through this resistor over here, and then going straight. Look at the soldering. Look at the way they soldered the thing. Let me bring you a close up of that soldering. See that soldering job? 2,000 rupees you are paying, and you're getting this. I mean, what? So it goes straight to the LED, goes again through a 100k resistor right there. It's a 22k resistor. It's a 100k resistor. It's not a 22k. It's 22 and yellow, 22 meg, and there's a diode going on. So it's basically it's a capacitor, and I'm going to take. Oh, my hands are getting really dirty. I'm going to take this thing, completely tear it down. This thing is not sharp. Come on. Okay. Now that has to come out, and that is what is all inside this thing. AC mains is coming. I believe you can see all these things. You can see I'm not going to touch those 2 points anywhere near that. You can see the wire is going inside that capacitor. This is truly a capacitor that don't want to touch that, but I certainly want to know the rating of that thing. This looks like the elephant foot. You know, the elephant foot that is in the where is that? I believe it's in a nuclear plant, Fukushima. No, not Fukushima, like Chernobyl. Yeah, the elephant foot inside Chernobyl nuclear reactor. And there is no markings on. There is no rate. I don't want to touch anywhere near that thing. That thing is super. The wires are super sticky. This thing doesn't even have a rating on it. And basically, the way they actually calculate the capacitance needed is there is an equation. There is a mathematical equation, that has to go with the frequency of operation, the voltage, the capacitance, and things like that, to actually find how much correction you need, and based on that you can actually calculate the value of capacitance you need. So if you ever want to save power, do not go for things like this, and don't get fooled. Don't just flush. You better flush your money down the toilet. That's a better thing you can do. Or like you can do some charity work or something. Do not fall for this kind of scam. Let me remind you once again, if you ever want to save power, all this thing is doing is connecting a capacitor straight to the AC mains. As you have already seen with the good thing right here, you just saw it. When I shorted these two pins together, it created a tiny spark. That's because this AC mains is connected straight to it without any resistance or resistor or anything. Oh, that thing is really gooey. I'm going to throw away this entire thing. I just want to keep the metallic case. And there's a hole right there for the LED. And basically, if you ever think about saving power by doing a thing like this, by attaching a thing like this, I nearly dropped my camera right there. So if you ever want to do that, let me adjust the camera. If you ever want to do that, then do something. Go get yourself a simple capacitor like this one over here. This is a fan capacitor. This is a 2.5 microfarad 440 volt rated capacitor that you can find on most of the electric fans. These are known as fan capacitors, and these are really cheap. In India you can buy it from somewhere around 40 rupees and upwards. And this one is made by a company called Keltron, which is a really good manufacturer for capacitors. And if you want to save power, all you need to do is get a capacitor, get a 440 volt rated capacitor, bring your power supply, attach it to the socket just like that, and turn that on. That really is it. If you want, you can add an LED, but that will consume power. That will consume additional power rather than saving power. Right now I'm saving power because I have a capacitor connected parallel to the grid, and that is what they are claiming that they can magically do. I mean, you got the point, right? So if you ever want to save power, don't just throw away your money. Go buy yourself a 40 rupees worth of capacitor. That is like less than $1. Go buy yourself a capacitor, plug this in your wall, and you're saving yourself money if you believe you are doing so. And basically this thing is actually doing something. If, as I mentioned earlier, if you have a capacity, if you have an inductive load connected to the grid, then having a capacitor in parallel with that will somewhat bring the power factor, provided that you have a closely matched capacitor. As I mentioned, there is an equation that you need to figure out to actually save the proper amount of electricity using a capacitor. You cannot just directly plug in a capacitor and claim that you are saving money. You need to go through all the mathematics and find the right spot, find the right amount of capacitance that is needed to be added to the grid for an overall right amount of power. So if I attach in any kind of inductive load to this power point, I may somehow be able to get some effectiveness from it, but I cannot, unfortunately, since I don't have any kind of equipments like a CRO or anything. I cannot show you that, and I don't have an LCR meter. I don't have any kind of other meters. Basically, I'm doing it on a budget. I'm doing this channel on a very limited budget. So yeah, so I'm just going to show you one last thing. If I take this out right now and do that, nothing happens. What? Oh, sorry, I forgot to turn the switch on. Let me do it once again. This time I bring the everything together and wait, what? Is this capacitor bad? Okay, let me show you something. I just want to make sure that the capacitor is fully discharged, and you've seen that the other one created a spark, and let me show you that. See, this one makes a much powerful bang than what this thing does. So yeah, that's all about power savers and things like that. If you are really interested in these kind of power saver things, I strongly recommend that you watch the EEV blogs video and Big Clive's video and Great Scouts video, and I think the Electro Boom has also made a video. Go ahead and check out those videos, because those have all the mathematics done for you so that you will get a better idea than my version of this video. So yeah, thanks for watching. I hope I explained everything correctly, and if you have any doubts, ask me in the comments below. Thanks for watching. See you in another video.